All right, for tonight's homework help over solving systems of equations by graphing, I'm going to do 5 problems with you. I'm going to do number 1, number 3, number 8, number 9, and number 12. Okay, so let's start with the ones on the front. Now, the ones on the front, if you notice, the ones on the front are in slope-intercept form. The ones on the back are in standard form. Let's start with the ones on the front because obviously they're the easiest ones. Let's take a look at number 1. Number 1 is y equals 3 half x minus 4, y equals negative 5 half x plus 2. So again, I'm always going to start by identifying my slope and my y-intercept. Okay, my slope is 3 over 2. My y-intercept is negative 4. So I start by putting a point at negative 4, and then I'm going to use my slope, which is positive 3 halves, and I'm going to rise 3, run 2, rise 3, run 2, and make sure that now I can put a line through them. I have actually no problem putting a line through them. I think that's a fine thing. But what I really want to make sure is that I have those points plotted. Okay, the ruler moved, whatever. Okay. Now I'm going to look at my second equation, which is y equals negative 5 half x plus 4. I'm sorry, my slope is negative 5 halves. Remember, that was something that we were having a lot of trouble with, so be really careful about that. Make sure, if it's negative, it should be going downhill. So make sure that you're falling 5 and running 2. When it's negative, instead of rising, we fall first. Okay? My y-intercept is 4, so that means I'm going to start at 4, and then I'm going to fall 5, run 2. Fall 5, run 2. I can kind of already see where the intersection is right there at 2, negative 1, but let's go ahead and connect these guys up just to be safe. Okay, I can see right there, that's where my solution is. So my solution is at 2, negative 1. Okay, let's try number 3. Number 3 is also pretty easy, again, because it's in slope-intercept form. Now, the only thing that's tricky about this is these are not in like moving through slope form. They're integers. So what I like to do is when I write down my slope, since I'm going to be using it to graph, I'm not just going to write 4. I'm going to write 4 over 1 because again, I want to see what it looks like when I graph it. My y-intercept is negative 3. So I start at negative 3, I'm going to rise 4, run 1, rise 4, run 1, and then connect these guys up. Okay, now I'm going to look at my second equation. Again, my slope is negative 2 over 1. Remember, if it's negative, it's going downhill. And my y-intercept is 3. So I'm going to start at 3, fall 2, run 1, fall 2, run 1, fall 2, run 1. I know, we already know our solution, but I'd like to be complete. Okay, so then when we connect these guys up, you can see that our solution is right there at 1, 1. Okay, those were pretty easy. They're a little trickier on the back when we look at these ones that are in slope-intercept in standard form. Now, remember, the first thing we try when we're doing standard form is we try the cover-up method because what if it works? Wouldn't that be great? So I'm gonna make my little table, remember, because I'm trying to find one that starts with 0, one that ends with 0. So if I want to start with 0, I have to cover up my 0. 4y equals 12. That means y equals 3. X equals 12. Well, that means 12, 0. Well, what's the problem with that? How is this graph, how does that not help me? Well, my graph doesn't go out to 12. If my graph went out to 12, this would be a perfectly fine way to do it, but it doesn't. So I need to get this thing in slope-intercept form. I could solve for y, but I'm kind of already halfway here. I know what the y-intercept is. I can just find the slope. Negative 3 over 12 reduces to negative 1/4. So I know my slope, I know my y-intercept. So my slope is negative 1/4. My y-intercept is positive 3. So I put a point at 3. I fall 1, run 4. Okay. So again, what I did there was I used what I know. Remember, I could go back and convert it into slope-intercept form, but remember, I've already got the y-intercept, and I've got a table with 2 values in it. If I've got a table, all I have to do is delta y over delta x to find to find my slope and my y-intercept, I already have slope-intercept form. So slope-intercept form would be y equals negative 1/4 x plus 3. If you converted it into slope-intercept form, you'd get the exact same thing. Okay. Now, here's the next tricky part. What's that? Okay. I see x equals. Anytime I see an equation that's either x equals or y equals, I'm thinking hoi vux. Well, this one ends in x, so I'm thinking v u x equals negative 4. That means I have a vertical line that goes up and down through x equals negative 4. Well, that means it's going to go through this point straight up and down. And they intersect right here at negative 4, 4. Okay? That was a little tricky. Okay, so let's try this one. This one, again, I'm going to start by I'm going to try the cover-up method. Okay? And if we need to, we'll go to the back of this page. Okay? If I cover up my x, I get y, if I cover up my x, I get y is negative 2. If I cover up my y, I get negative 4. So I have 1 point at 0, negative 2, 1 point at negative 4, 0. There's my line. Okay? And I can see, if I look at this, if they ask me for the slope with this information, I can tell what the slope is. I'm going down 2 over 4, down 1 over 2, negative 1/2. Okay? I know my y-intercept, so if I had to, I could say the equation is y equals negative 1/2 x minus 2. Because I have that information. I've collected that information from standard form. Now let's look at this one. Well, the y-intercept on this one, hold on, let me get the right pen. The y-intercept on this one is easy. Because if I divide both sides by 2, I get negative 4. But then I see this. If I divide both sides by 3, I get negative 8/3. So I'm not really liking that. So I'm going to try plugging in a number and seeing what I get. Okay, well, I know I've got thirds, so let's try plugging in a multiple of 3 in for x. So just for the heck of it, let's put in 6. I don't know why. Well, I can't put 6. Let's put 3. Okay? Okay, so 3 times 3 plus 2y equals negative 8. 9 plus 2y equals negative 8. If I subtract 9 from both sides, 2y equals negative 17. Well, that's no good. Okay, we're going to have to convert this. Do you see how I'm doing all this work and I'm not getting any good results? That means I have to convert it. I've spent enough time on this, I'm going to have to convert it into slope-intercept form. This is what I'm talking about, how like when I said you have to, I could try numbers and test them all day long, but the fact of the matter is, it's faster for me to just go ahead and convert it. So the equation is 3x plus 2y equals negative 8. So I'm going to subtract 3x. Remember, I want to get 2y by itself. So I'm going to subtract 3x from both sides. 2y equals negative 3x plus 8. When I divide both sides by 2, I get y equals negative 3/2 x plus 4. Okay? So negative 3/2 x plus 4. So I'm going to start at 4. I'm going to go down 3 over 2, down 3 over 2, down 3 over 2. What did I do wrong? Oh, that's supposed to be minus 4, wasn't it? Yep, minus 4. Bad Maggie. Okay, let's try that again. It's supposed to be minus 4. Okay, so I start at negative 4. I go down 3 over 2 doesn't help me, so I'm going to go over 2 up 3. Back to up 3. Does everybody know what mistake I made there, by the way? Did everybody see what I did wrong? First of all, I knew from here that my y-intercept was negative 4. And over here, this was a negative 8. I didn't write that that was negative, which means I didn't write that that was negative 4. This is one of the reasons why we have to be super ultra careful. I've already told you guys I'm never going to lie to you when I make a mistake. I'm never going to tell you, oh, I meant to do that. I did not mean to do that, y'all. Okay? Now when I connect these up, this is correct. I see that my intersection is negative 2, negative 1. Okay? Sometimes it's best to cut your losses with with the cover-up method. Okay, let's look at this last one here. I'm going to be honest with you, when I see 5x and 4s, I know that they don't divide evenly. So I'm feeling like this top one, I'm probably going to have to just go ahead and count my losses and convert. The bottom one, I see that when I do the cover-up method, I'm going to have x equals 12, which I can't graph on this. So I'm just going to go ahead and convert them both. Okay, and I will do that work with you on the back here. Okay, so I have 5x minus 4y equals negative 4. Remember, I want to get the y term by itself. And remember, that negative is part of the y term. So I'm going to subtract 5x from both sides. I have negative 4y equals negative 5x minus 4. I divide everything by negative 4 because I want y by itself. I get y equals 5/4 x plus 1. Okay, so my first equation works out to 5/4 x plus 1. So when I graph that, I start at 1, I rise 5, run 4, I fall 5, go back 4, okay, and then, hang on a second, and then I put my line, I do my line, okay. Now, I'm going to do the other one. The next equation that I have to convert is x minus 4y equals 12. Remember, I want to get my y term by itself, so I subtract x from both sides. This zeroes out. I have negative 4y equals negative 1x plus 12. Remember, I don't like having that invisible 1 there. I mean, when I see that negative, I kind of forget it's there. Every time I see a negative, I want to put a 1 in front of it. Okay? Now, I want to divide everything by negative 4 because I want to get that y by itself. Well, those cancel out. The negatives cancel out, so I have 1/4, I'm sorry, that's a 1. I don't know what happened. 1/4 x minus 3. Then that's my second equation. Y equals 1/4 x minus 3. Where is it? Oh my gosh, it's all the way down here. Y equals 1/4 x minus 3. So I'm going to start at negative 3. And I'm going to rise 1, run 4. I'm going to go backwards 1. Oh, there's my intersection right there. Okay? So these two lines cross at negative 4, negative 4. Okay? I hope I've given you enough hints that you'll be able to finish the rest of them. If you have any questions, make sure that you write them down so you can ask me tomorrow.